Built in 1973, the upmarket Mariston Hotel is set in picturesque secure gardens in the heart of Johannesburg. The hotel is centrally located, providing residents with easy access to the Johannesburg CBD, various tertiary education facilities, and major transportation routes. The Mariston is one of South Africa's top student destinations and a contracted supplier of the accommodation via student bursaries for higher education institutions. The building is one of the larger high-rise developments in the Johannesburg CBD at 32 stories and boasts accommodation for 2,000 students in 1,000 hotel apartments. As such, the electrical and mechanical infrastructure is equally large. GreenAfrica Industries set about on a task to reduce the energy cost of one of the major infrastructure components, the hot water system. The Mariston has the largest single hot water plant in South Africa for residential hot water usage, storage vessels, each heating 40,000 litres of water by means of an electric resistive elements. Total installed heating capacity is 1 megawatt. Since the cost of energy in South Africa has steadily escalated, GreenAfrica was met with a challenge to reduce the energy usage and in so doing, reduce the running cost of the hot water plant. GreenAfrica's expertise in the retrofit and implementation of heat pump technology for this type of water heating application is well established, and so engineering one of the largest retrofits in the Southern Hemisphere began. The team had the task of engineering and implementing a system that would not only reduce the energy cost but also provide a reasonable return on investment. First was get all the existing system information. This consisted of operating pressures, actual energy consumption, system performance, and operating conditions. Second was to design a heat pump solution capable of delivering the hot water volume to meet the inhabitants' demand. Luckily, space was available to install large commercial heat pumps in the basement, adjacent to the plant room. This enabled the team to design a heat pump system with high output, small footprint, and redundancy. In addition, a plan was put in motion to upgrade the old piping systems. The anticipated energy reduction would be 800 kilowatts from the installed capacity, but could such a large-scale implementation be done on such an old plant? The client issued the go-ahead and the project passed from the audit and design phase to the project management phase. Site layout diagrams were produced as well as electrical and plumbing schematics. Equipment was specified and ordered and the project plan was created. Over the next few weeks, site preparation was done by the GreenAfrica team. Next, the large heat pump water heaters arrived. In the warehouse, the machines were prepared for delivery. Most of the plumbing and electrical reticulation had been prepared for the machine's arrival, and the day had come for delivery of the large machines to site. The GreenAfrica team readied themselves for one of the largest system deliveries on the continent. Each heat pump was carefully transported into the basement area with only millimeters to spare. The heat pumps were placed in their final position and work was immediately underway to connect them to the 4 large tanks. This process was carefully managed and planned in order to minimize system downtime, as the building was fully occupied. Luckily, the site was made ready in anticipation of the heat pump arrival, and the downtime of the hot water system was expected to be minimal. Both the plumbing and electrical teams worked to have the machines ready for operation. There would be 2 phases in getting the system to final operation level. Firstly, the machines would be plumbed and electrified for the initial operation. Secondly, the ducting would be installed to finalize the implementation. The GreenAfrica team completed the first phase of plumbing and electrical installation in a record time of 6 days. The system reticulation was now ready to be tested. Firstly, the system was electrically checked. A few problems were encountered and quickly fixed. Then, the big test. The piping system was ready to be pressurized. The valves between the tanks and heat pumps were carefully opened, remembering that the operating pressure of the system was more than double the normal standard. The PPR piping system was pressurized with no leaks. The 9 heat pumps were now ready to run as part of the first phase. Final system checks were completed and the main electrical control panel was turned on. Success! The system booted up with no errors. One small problem had cropped up. The system could not be remotely monitored because the modem signal strength was too low in the basement. A new antenna was ordered to fix this, but it didn't prevent the system from working. The moment had arrived to press the on button. The GreenAfrica team watched as months of hard work were about to be tested. Each machine was turned on, and within 90 seconds, all 9 heat pumps were running without error. The team were relieved, and the system was monitored manually for 24 hours until the modem antenna arrived. The result? The heat pump system was working at full steam, but without the ducting phase complete. The efficiency severely lacked. Over the next 8 days, the team would once again work tirelessly to finish installing the ducting elements. Once the main ducting components were installed, an immediate and drastic efficiency was noticed, with the tank temperatures fully recovering daily after major hot water demand. As a last step to this enormous project, the local university was called in to verify the electrical savings. And the results? Well, the facts speak for themselves. GreenAfrica wishes to thank the team and managers for an outstanding job.